Welcome to the Shack of M1 Geo. About a year ago I repaired my Kiska T12 soldering station, soldering line setup, and almost exactly a year later it seems that the quick 8610W has decided to die on me. And I just popped the lid off. The problem is that the fan inside it runs at full speed all the time, so the CPU has basically lost control of it. I was soldering up this little PCB most of the way through that, and really annoyingly the fan all of a sudden went from very low, which is how I normally solder with it, to full speed, absolutely like hurricane gal force. So I guess the the control FET has died in it, so can have a quick look at that and see if we can get it going again and document the process in case anybody else has the issue. I did have a quick look around on YouTube and on the web and didn't find anything. So the problem is, as soon as I turn the power on, the fan spins up to full speed, even when normally the screen's got 3 dashes, or all dashes, and it says sleep here. So normally the fan would be off now, and yeah, lifting the thing off the cradle, everything responds. It starts to heat up exactly as I expect, and I can already feel the hot air coming out of this, and cool down again. And then when it gets below about 100 degrees, when all these lines come up, it would normally stop the fan, but it doesn't. So the only way to shut that up is to kill it. So looking inside here, there's a few different FETs and stuff. I'm not sure of the schematic or anything like that yet. I've just popped the lid off, but take the PCB out and have a look, see what I can find. Okay, so I've got the back of the control panel out, well, all the wiring off the back of the control panel, and this is where the fan connects here. So I'm going to have a quick look around here. I'm guessing there's going to be some kind of some kind of trace on the PCB, probably back to one of these FETs here. I guess the biggest one probably controls the heater. Maybe this one controls the fan. Haven't got a clue yet. I'm going to look into it. Just wanted to point out, for everybody's benefit, on mine, all of these were plugged in, apart from these two things here. Again, don't know what any of this stuff is. It goes into the cable. It was the grey and white wires. Grey was on this one, and white was on this one. So the left one here, this side, this one was grey, this one was white. Right, so when you take this out, the first thing that happened for me would all of these bits fell out, the buttons. Some of them had been modified by a man with some cutters. So these for me were on there. As I'm looking at it like this, they were on this side. So on the right side of the innards, so the left side of the panel from the front. Not sure which of the two controls that is, can't remember. But yeah, keeping track of the ones that have been clipped short is going to prevent you from having to faff around with them. Interesting, I didn't realise, but the heater on this is mains powered. So the mains in comes from the back, wiggles round through the power switch, and then onto one of these red connectors that go up here where it says 220 volt here and here, and then the hot connector there as well. So if you look at the back of the board, see that these two are connected together. So this trace connects these two and these two. One side of it goes to this, which is the back of this heater connector, and then the other side goes round to this heatsink here, which is a BTA 41 800C. That's a AC switching triac for use with microcontrollers, basically. So exactly what you would expect for a mains heater, and just AC switching triac. So it allows them to pulse chop the mains and basically vary the heater power by chopping up the AC. What else is going on here? So there's only two other things with a heatsink. This one's a 7805, and it's connected to some bridge rectifiers. There's also a little 7805 here as well. 7805, 7806. It's another 7805. I guess one of them's for this op-amp stuff. It's probably doing the heater measurement stuff, and they want it to be quiet. A lot of the chips have had the numbers ground off, so I can't see what the main processor is. It looks to be like an 8-bit, probably an Atmel or something, looking at the pinout, but yeah, normally you go where the crystal is, and so that gives you a bit of a clue, but nothing like that on here, so don't really know. Looks to be roughly where the power is, like an Atmel part, 18 mega or something, but yeah, without researching it, don't know. But a noise suppression for the not enough, but a bit of noise suppression for chopping up the mains. Bridge rectifiers for 2 supply rails. So yeah, don't think it's this one. This is 7805, and another one here. I guess these two are powering this processor and stuff, and the other one's probably powering the op amps or something. Not traced this out. So that leaves this part here. This is a TIP122, which is a NPN part. There's something behind that. Didn't see that before. What's that? A TLO431. That's a precision voltage reference, so it's a voltage regulator, shunt regulator, so there'll be, yeah, here. So from the positive supply through that down to ground, and that will give a precision voltage on there. So they'll be using that as a probably temperature stable reference or something. I'm not entirely sure, but that'll be giving some kind of voltage reference. Anyway, back to this TIP 122. That's a 4 amp sort of relatively low voltage. I think it's 100 volt, but I buzzed it out. And you see the fan connector here, fan plus, fan minus. So I buzzed that out. The fan plus goes to top of this capacitor C7, and also this electrolytic, the positive side of that here. Not quite sure where it goes, because it actually comes along here to a via that isn't, or it is, but it's a multi-layer board. It doesn't go to anywhere on this side. Maybe it does. No, I don't think it does. I think it lines up with any of those vias on this side. Anyway, yeah, so it comes up to here, but it's basically 0 ohms to this rightmost pin on this part, which I guess is the emitter, but I haven't got the data sheet handy. But it connects to that anyway, so I'm guessing that's doing some kind of PWM, and then this smooths it out a bit for the motor and sends it out there. So let's take this part off and measure it, see if it's any good in the transistor tester. Okay, alright, got the transistor out. Just having a look at the data sheet, and it's a Darlington pair, I think. It says 122 is NPN. It's got some resistors, 8k and 120 ohm inside it as well. Right, I've got here a transistor tester, and let's plug it in, see what it says. I hand out the video so you can see what's going on. There we go, and then press the test button. Try and get the fluorescent light out of it. So this thinks we've got 2 diodes, and 74 ohms between 2 and 3. So that would be 2 and 3 would be. So the pinout is so it's 1, 2, 3 on here. Ignore this 2. This is just telling you the procedure of doing things, discharging and stuff. Yeah, so it's pinout 1, 2, 3. 2 and 3 is collector to emitter. So its pinout here is base, collector, emitter. So 2 to 3. It's gone to sleep now. 2 to 3 is the base emitter junction. So I think there's a 74 ohm resistor there, and that there's diodes between 1 and 2. What would that be? That would be base to collector. And 1 and 3, which would be base to emitter. There's a body diode in there as well, so I guess that is possible. I mean, there are some diodes in here. But yeah, I think the main issue is that it's 74 ohm between the two of them, so I guess that's what's happened. Right, I'm going to order a new one of those. I suspect that's probably what's dead. And we'll reconvene. Okay, several days have passed and I'm now the proud owner of 5 of these TIP122 parts. Pretty much the same, certainly from the outside. I ordered these immediately after finding the previous one had failed, and then went looking for them in my junk boxes and spare transistor bags and stuff, on the assumption that as soon as I've ordered them, then the ones I had already would become evident and turn up, but that didn't work, so we had to wait. But here they are, so let's I'll pause the video again, get one of these out of the bag. These come from eBay, so hopefully they're okay. We'll test them, see if they look any different to the original one. Hopefully they do, because if not, we haven't found the fault. But yeah, fingers crossed. This one shows up as a nice Darlington transistor, and we're away to go. So let's get one out and give it a test. Okay, so I've got the 3 out of the bag. Sorry, 5. I can't count. Was difficult to do actually, but got them out. Transistor tester here as well, with its annoying reflection. Okay, let's put one of them in here and give it a go. I've not seen this yet, so please work. Yay! It comes up as a transistor with a body diode, so NPN body diode. A pretty poor gain of 40, but that's fairly common for power transistors. Yeah, and then forward voltage, so the turn on voltage 1.29 volt, so that's about 1.3. Let's test another one. 1.3 would be 0.65 volt, and obviously remembering it's a Darlington, so yeah, slightly higher gain. So these seem good, which is excellent. These measure as transistors rather than diodes and resistors. 1.3 and a slightly lower gain, so we don't use that one. Second one looked okay. 41. Any of these would be fine in all honesty. I'm just playing. 42. I reckon I'll go. I think it was this one that was the good one. They're all good, but you know what I mean, the better one. 45, so this one's got the highest gain. Let's go with this one. And there's the other 4 here, so cool. I'm really pleased that that's at least showing a positive difference. Yeah, so you know, it's something that we found that's different and wrong, so let's put it back in there, and hopefully I'm pretty confident that's going to fix it. But let's cut here, get the rest of the soldering station back out, or the PCB out at least, and put that in. Okay, right, I actually took 2 out. I'll put the other 3 in here. This will be the go back into the box of spare transistors. Here's the rest of the stuff. I bundled it all up to try and keep all the screws and everything. Plan being, one of these will go in the PCB and hopefully work. The other one can live in the case. I'll secure it in there somehow as a spare, and then label it as a spare in case it goes again. I will have one inside it, and I won't have to dig around in the box because I will inevitably lose these 3. These will never be seen again. So, yeah, we shall leave one in the machine as a spare. So if it does go again, there's one there, and I don't have any other use for them. So we've got the dead transistor here. These 2 new ones. Sorry, get my hand out. The PCB, and then the screws. And there's this little machine screw, which is like the rest of these are self tappers that hold the front panel in. There's 8 black case screws, and 1 machine screw here, which is these 2 are threaded, and these ones are self tappers. Goes in here. So picking out one of these. Try and do this with the wrong hand, but okay, get that in like so. Focus on this is going to be interesting. Easily screws in. Just want to nip it up just gently enough for now. It's apparently the wrong size screw bit. I was using a Phillips size 2 before. Let's go back to that. PH2. And that fits properly. Cool. Okay. Now, I'm not going to be able to solder this with one hand, so I'll pause it a second and come back when it's done. Okay, so new transistor in, soldered in. Ooh, stay at that screen, and then a bit of flux off to clean the residue off, etc. I used leaded solder. Sorry, I'm guessing that this is lead free. Just looking at the dullness of the joint compared to, I don't know if it's visible, but mine are quite bright, the rest is quite dull, so guessing it was made lead free, don't know. There's a few bits of lint around as I used it to dry the board off. I'll nip this up with a proper screwdriver, just make sure it's tight. There was no thermal compound on the one I took out, I haven't put any on. It looks like it's not connected to anything electrically either, so just tucked in there. Okay, let's reassemble the unit and see if she goes. Reassembling, mine were set up so that this side had the cut ones and this side didn't. So I've put them back in like this. I'm holding the unit at an awkward angle just because otherwise they fall out with the curvature of the front. So reassembling is a bit of a balancing act, but we'll get there. Okay, got the control ball back in. There's 4 screws. These are going into plastic, and they're the self-tappers. My advice would be to try and find the original thread rather than cut a new one. So I pop the screws in the hole, gently turn it backwards, you'll feel it sort of rise up and then drop in, where it's found its old thread, and then use that again. Otherwise you'll end up cutting a new thread, which will, you only get a couple of goes at that before it chews the plastic up completely. Screwing into this as well, it's it's Chinesium, it's cheese grade aluminium, so it's not very strong. So again, carefully doing that up. Okay, so got to connect the mains cables back up, a couple of sensor cables and a fan and stuff, and then we should be away. Okay, got all the cabling on, everything looks good. Resealed these up. The grey and white heater cables, and now they've got mains on them, so I check those out nice and tightly and stuff. Yeah, keep them away from everything. A little bit sketchy how they've used such thin wire. Actually, this claims to be 1 kilowatt. So yeah, it's only this 4 amp mains fuse on the back that's stopping that drawing more. So yeah, this does not look like it would handle a kilowatt, this wire. But there we go. Not a design review, I'm just getting the thing going again. It genuinely surprised me that it's using, I would have thought it would be using like 24 volt or something like soldering irons tend to do, rather than mains, but I guess at a kilowatt that would be quite a bit of a current, so makes sense. I just never really thought of it. Okay, let's plug this in. I genuinely haven't done this yet, so we're going to learn together. Of course, on my shack, this is that's a fair motto for how everything works here. Let's not put my thumb behind the connector and blow my fingers off. Trying to do this with one hand is quite difficult. Let me use the front panel as a... There we go. Right, so let's turn this on. If the fan spins up straight away, we know we've not fixed anything, and if it doesn't, we've won. Hey! That's it. Because before, at this point, it would have been screaming. So, don't remember seeing that on the front panel before. Oh, degrees C, yeah, that I do. Okay, let's take the iron out of the holster. Yeah. It started at a much lower rate. That's awesome, and is up to temperature. Oh, yes. pleased with that, and that's fixed it. Right, pretty much the show's over, folks. All that remains then, I can feel this blowing warm air down my leg. Let's stop it from ruining my clothing. Okay, so sped up slightly. You can see the temperature dropping, and then when it gets to 100 degrees C, it should stop. So, quite slow now because the fan's obviously a lower rate. I thought it sped itself up. Maybe it doesn't. But I mean, at least I can do that now, so. Just turn it back down to where I have it. So yeah, eventually it will drop below 100, and then we'll get the 3 dashes up, and it should cut out. I'm certain we fixed this, so. Perfect. Alright, all that's remaining then is for me to button this up, and then I can get back to what I was actually soldering. Should also add that the inside of this got some foam stuff in it, and I guess it's to quieten it down a bit, but it catches a bit when you dismantle it, so be careful when you try and slide the cover off, or you don't rip it too badly. Difficult to get it all in shot, but there you go. A bit of an idea. Right, all buttoned back up. Excellent work. So yeah, one thing I did forget to mention was just to make sure that the inside of the LCD is clean when you put it back in here. After mine had been in the bag, there was some like dust or something on it, and yeah, that was a bit annoying. So I popped that control panel back out very carefully, cleaned the dust off, and put it back together again. But after that, all the case screwed back on. No problem at all. It's a bit dusty. It normally just lives in that little alcove that you saw at the beginning. And runs flawlessly, so hopefully that was useful to somebody. Probably not, but a mini voyage of discovery. And yeah, I'll put a TLDR in the comments section with the parts and stuff, and a very quick summary of what's going on inside, so if anybody's interested, there's some notes in the summary in the description as well. Thanks for watching. If you made it all the way through, I suspect most people would jump the boring bits, but hopefully it was useful, and thanks for watching.